Hello everyone, for this tutorial video, I'd like to begin teaching applications of derivatives, starting with the definition of the derivative being the rate of change, and what this means graphically. We know from proving derivatives that the algebraic definition of the derivative is as change in x approaches 0, function of x plus change in x minus function of x all over change in x. But a more graphical application of what this means is to draw a line tangent to our function, which means intersecting at one point only, and seeing that the derivative gives the slope of this line exactly. So because we know what the derivative is algebraically, we can get an equation for the line, which would be function 2 minus function 1 equals derivative times x2 minus x1. By simply multiplying the derivative by its denominator, which leaves us with a numerator only, i.e. function 2 minus function 1. Another thing we can do, mathematically speaking, is tell where the function is increasing or decreasing because of the fact the derivative is the rate of change. If the derivative is positive, the function is increasing, and if the derivative is negative, the function is decreasing. Lastly, if the derivative is 0, the function is remaining the same. We can determine exactly where the function is not increasing or decreasing by computing the derivative, then setting it to 0, then finding the x points that satisfy this equation, which will be the subject of the next tutorial video discussing critical points, and how you can use critical points not only to find where the derivative is 0, but also to find endpoints of increasing or decreasing intervals, because we know on any given graph, if we have a flat horizontal section, then any section to left or right of that is not also horizontal must be increasing or decreasing. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.